Namaste. I, Simran Kaushal, welcome everyone on the brand new episode of Science Bits only on Bharata First. This season is all about science, which is simplified in a short, crisp, and a unique manner by the experts. This platform provides a unique opportunity to explore your scientific temper and skills. Science Bits involves explanation of the topics ranging from the recent trends and developments in the field of science and technology to the discussion of the previous year questions and potential concepts which are important from the perspective of competitive exams. Let your curiosity out and ask questions through a form whose link has been provided in the description box below. Do make use of this opportunity. Now, I would like to introduce to our science expert, Dr. T.V. Venkateshwaran, who is here with us to answer the questions. Dr. T.V. Venkateshwaran is a senior scientist at Vigyan Prasar, New Delhi. He is also founder of India Science Wire. So, the first question for today is,
Very good question. So let me share my screen and then answer. Okay. So there is a very famous quantum mechanics thought experiment. It's not an experiment which is actually performed, but kind of in your thought you can perform this. So it's called as thought experiment. Assume that there is a cat inside a sealed box. Okay. So the cat is inside the sealed box. Inside that there is a radioactive material. Okay, the radioactive material, there is only one atom. Okay, so that radioactive material can decay at any time because there is only one atom. The moment it decays, the radioactivity uh, actuates a mechanism whereby a hammer falls on a glass vial in which there is poison. Okay, so if the hammer falls, the poison will spread inside and then the cat will die. But if the hammer doesn't fall, the cat will keep on alive. Of course, you will ask what will the cat eat, etc. In thought experiment, we don't discuss that part. We assume you have some way the cat is able to eat something or whatever, right? Yeah, this is not exactly about cat. It's a thought experiment to make it more interesting. Now it's a sealed one. Okay, so you cannot see what is inside. Let's say after a few days, can you tell whether the cat is alive or not? No way. But suppose you open and you find cat is alive. Can you say that for the past 5 days the cat was alive? That's an important question. Okay, for which our common sense will say that yes, of course, cat should have been alive. But how do you know that cat was alive? What is the proof that cat was alive? That's a big question. Okay, so within quantum mechanics, the idea is to say that from the time that you seal and from the time that you okay, opened and saw whether the cat is alive or dead, during that whole period, the cat was simultaneously alive and dead. This is what is called as quantum superposition. Okay, so in quantum superposition, you exist in two states simultaneously. Which one? Once you observe, it will be clear. Okay, till you observe, it exists in two positions simultaneously. Uh, One of the way that we can see that simultaneous existence is, say, for example, you have an electron gun. You send an electron. Let's say there is a slit like this with the two holes. Okay, normally we will expect that the electron will go like this or electron will go like this. When it goes like this, it should hit the screen somewhere here. If it goes here, it should hit the screen somewhere here. Only two lines should fall, but that's not what actually happens. What happens is that you have parallel lines like this. Okay, in the screen you will find a parallel line like this. The center one will be the brightest, then less brighter, even less brighter, like that. The parallel lines will keep on continuing. So what does it mean? So if I look at a line like this, okay, this line like this could have happened only when a atom goes like this and goes in this way, which is not the usual format that we will think a particle will move. But suppose if this was a wave, electron was a wave, then this is what we will observe. Okay. So now the question is whether the electron went through this slit or this slit. That's in superposition. If you look at a particular electron, okay, a particular electron here, making a dot here, whether this came from this slit or this slit, you cannot say, it's in superposition. But the moment you start observing, that is, you observe the electron, then what will happen is that the electron will go and fall on only one point. Okay, so the superposition is released. So this is the quantum idea of superposition. Similarly, there is something called as quantum entanglement. What does this quantum entanglement mean? Suppose if I take, let's say, a square and a circle, okay, a square coin and a circle coin. I take two of them, okay, out of a box which contains squares and circles. Then I have four possibilities, right? I can have a circle circle or a square circle or circle square or square square. Then each of them have 25% possibility. This combination has 25% probability. This is something that we know very simply. But suppose if there is a rule which says that if the first one is circle, the second one should be circle. If the first one is square, the second one should be square. Then what happens is that we have something called as entanglement. What happens in the first decides what should be the second. Here, whatever be the first, whether the first is circle or square, the second one is not dependent. When the first one is circle, the second one can be circle or can be square. If the first one is square, the second one can be a circle or a square. Both are possible. But here, because of the entanglement, if the first one is circle, the second has to be circle. If the first one is square, the second has to be square, right? So this is called as quantum entanglement. So this is another property in quantum mechanics. Okay. So there is something called as decoherence. That is, if when something is in a superposition, when you observe it, it either becomes heads or tails. Say, for example, if I throw a coin, the coin is spinning in the air. As long as it is spinning in the air, you don't know the result, right? So it can be either head or tail. So it is in a superposition. But the moment it falls and then you observe that it is head, it decoheres. It becomes either head or tail. It resolves into one, right? So these are all some quantum mechanical idea. From using that quantum mechanical idea, you can create certain computer structure. Okay. Normally, in an ordinary computer, what we create is what is called as a switch. Okay, so the switch can have two positions: on, off. Okay, on, off. So you can call on as 0, off as 1. You can call any name, doesn't matter. Okay, so because it's a switch, it can only have two positions: on, off, 0, 1. Okay, so binary. So that is bit. Okay, now I can have quantum bit, qubit. So in the qubit, remember that things can live in a superposition, right? So there is one position, there is another position. Now I can have a superposition, right? So now I have by same switch, here I can only represent two, but with the same switch, I can here represent multiple points. Okay, here there are only two possibilities, but here I can get multiple points. So because of this, that it can be either 0, 1, or both, that is a superposition. The computation with the quantum system will be much faster. Okay, in the traditional system, you go one by one and then find the answer. But in a superposition, I can change the possibilities. Okay, as many possibilities I can sort out, and then I can get the answer faster. Okay, so that's the quantum mechanics that's used. For example, one of the quantum computers structure as of now looks like this. Okay, so at this point is where the qubits are stored. Okay, and you have to cool it with liquid helium because it has to be at very 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 low temperature for quantum mechanical effect to take place. Okay, here is where the qubits are stored. So if you look at the specific qubit, it'll look like this. Okay, so it'll have a sealed metal casing, and inside it you'll have the coolant going around so that you can keep it cool. Okay, so then you'll have electrical component. So basically, leads coming out of this bit, and there is a small pit-like cavity where it can store 1 qubit. Okay, so that's how the qubit systems are done in quantum computing. So the quantum computing is essentially using quantum mechanical ideas like superposition, decoherence to build a computing machine. And because in the quantum mechanics, it's not only 0 or 1, both are also possible. Then more information can be stored in a less place. So more faster your computations can take place. That's what is happening in a